Okay, let's do 1.1.1. We have 1.1.1, 2x plus 1 squared minus 4 being equals to 0. We are supposed to solve for x. So the most way, or the most technique that most people are going to use is to square this first and then subtract 4 and factorize. So let's go ahead and take that road. If we square that, we get 2x multiplied by 2x, which is 4x squared. And then 2x multiplied by 1, that gives you 2x. You multiply that by 2, you get 4x. And then plus 1 multiplied by plus 1, we get plus 1. So we have solved that. And then everything minus 4. This is equals to 0. So we're going to have 4x squared plus 4x plus 1 minus 4 will give us minus 3. And this is equals to 0. So this right here in front of us is what we needed to factorize. And in doing that, we're going to get 2x plus 3 multiplied by 2x minus 3 being equals to 0. It's not quite an easy task to factorize when the coefficient of x squared is not 1 for most people. So in a situation like this, you can use the trial and error to really find out the factors that will lead you back to what you're factorizing. Other people would even use quadratic somewhere else, and then after they see the way their solutions look like, then they put it back in. Right here it is minus 1 and not minus 3. Let's multiply it out and see if we go back to the same expression. If we do that, we get 4x squared minus 2x plus 6x minus 3. So 4x squared plus 4x minus 3. So there we go. We can prove to see if the way we're factorizing is correct. Okay, and then now to get our values of x, 2x plus 3 is equals to 0. 2x is equals to minus 3. X is equals to minus 3 over 2. On the other hand, we have 2x minus 1 is equals to 0. So 2x is equals to 1. X is equals to a half. So there we go. These are our values of x in 1.1.1. If you take a look at 1.1.2, correct to 2 decimal places. So we know that we are using the quadratic equation in 1.1.2. Well, I think we can go to 1.1.3. I don't think there's anyone who needs any help with using the quadratic equation. Minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So in doing 1.1.3, we have an inequality there. We have 15x minus 4 being less than 9x squared. So okay, let's take 9x squared to the left hand side. We're going to get minus 9x squared plus 15x minus 4 being less than 0. Right, now we can go ahead and find our critical values. Okay, and then in finding our critical values, we can drop the inequality and replace it with an equals to sign. So we're going to have minus 9x squared plus 15x minus 4 being equals to 0. If we divide everything by minus 1, we get 9x squared minus 15x plus 4 being equals to 0. So there you go. We need to factorize this. Again, the coefficient of x squared is not 1. So it's quite difficult to factorize for most people, including myself. You know, when the coefficient of x squared is not 1, I really have to think about it. So in the exam, you use the quadratic equation, but you use it somewhere else, right? So that you can see the values of x that you're supposed to get when you factorize, and then you can sort of play around with the numbers, and it makes it easier to see the factors you're supposed to use. So in factorizing this, we get 3x minus 1 multiplied by 3x minus 4. This is equals to 0. So x is equals to 1 over 3, or x is equals to 4 over 3. These are our critical values. These are our critical values. But what do we want to do with our critical values? Okay, let me show you. If you've been watching the channel, if you've been watching my videos, this is the approach I always take. So we have two possible sets of solutions, right? It's either x lies between the critical values or lies outside the critical values. What do I even mean by that? Let me show you. It's either x lies between 1 over 3 and 4 over 3, or x lies outside. I mean that x is less than 1 over 3, or x is greater than 4 over 3. These two will always be our possible solutions for all inequalities of this nature. So we just need to test and see if the right solution is option A or option B. But it's always going to be these two options. So how do we test where our solution lies? Well, we can start here. We can take a number between, because we are proposing that x is between 1 over 3 and 4 over 3. So we can take a number between 1 over 3 and 4 over 3 and substitute it in our inequality and see if it is going to be satisfied. Or we can also take a number that is outside this range, the number that is less than 1 over 3, or a number that is greater than 4 over 3. Okay, so I'm going to go with option B. I will take a number that is less than 1 over 3. A number that is less than 1 over 3 is 0. I always like substituting 0, because when I substitute 0, it makes my life less complicated. So if I substitute 0, take a look here. 15x, if x is 0, then that collapses. We are left with only minus 4 being less than. Okay, if we substitute 0 here, that collapses also. We're going to be left with 0. So is 0 greater than minus 4? D is greater than minus 4. So this means that our answer lies here and not here. Our answer is not between 1 over 3 and 4 over 3. It is outside those critical values. So that is not our solution. Our solution is that which we have there. X less than 1 over 3, x greater than 4 over 3. So there we go, 1.1.3. What about 1.1.4? Quite an interesting question. Mark allocation, 5 marks. But there ain't nothing to it but to do it. So let's take a look. We have the square root of 2x minus 2 minus the square root of 7 minus 2x being equals to 1. Okay, so where do we start? Usually with these problems, maybe we have equals to 0 here, and we take one square root to the other side and square both sides. But if you take a look at it, we have 1 there. So what do we do in that case? Well, it's really up to us. We can square both sides from the get-go. We can square both sides right now, or we can take these to the right hand side and then square both sides. But both ways would work, right? Because we are not doing anything mathematically wrong per se, so it should be fine. So let's take this to the right hand side. Why am I taking that and not this? Because when I take minus square root of 7 minus 2x, then it will become positive. It's always easier to deal with positive terms. Okay, so the square root of 2x minus 2 is equals to 1 plus the square root of 7 minus 2x. Right, sticking to the basics. Okay, let's square both sides. let's square both sides. Obviously, when we square both sides, it's going to be a bit complicated because we have 1 plus the square root of this thing. If we had a number multiplying the square root, which is our usual case, it will be a bit more simple. But it's the exam, things are going to be difficult. So we just have to do it. There's no way around it, really. So in squaring the left-hand side, you're going to get 2x minus 2. When we square the right-hand side, 1 multiplied by 1 is 1. And then 1 multiplied by the square root of 7 minus 2x is the square root of 7 minus 2x. You multiply that by 2, you get plus 2, the square root of 7 minus 2x. And then again, when you multiply the square root of 7 minus 2x by the square root of 7 minus 2x, we are gonna get 7 minus 2x, right? If you're asking yourself, what just happened? We're moving too fast. I don't see what is happening. So you can write these as 2 brackets and multiply out. Eventually, you're gonna get here. Okay, I've talked about how you can actually do it without having 2 brackets. You know, it's not quite a difficult task, but you can look that up and yeah, add some skills to your arsenal, get better. Okay, so 2x minus 2 is equals to, we have 1 plus 7. Okay, 1 plus 7, that is 8. So we have 8. And then we have minus 2x. Minus 2x doesn't have a like term. So we're just going to have plus 2 square root of 7 minus 2x minus 2x. Doesn't have a like term. So let's take these 8 and minus 2x to the left hand side. We're not just taking it to the left hand side for fun, okay? We are grouping like terms here. 8 and minus 2 would be better if they're on the same side. 2x and minus 2x, our life would be easier if they are on the same side. So we're just not doing stuff for the sake of just doing it. There's an idea behind it. So if we take minus 2x to the right hand side, we're going to have 2x plus 2x, which is 4x. Minus 2 minus 8 minus 10. And this is equals to 2 square root of 7 minus 2x. Are we making any progress? Yes, we are, because now we are at that point which we are used to, right? So let's go ahead and square both sides. Let's go ahead and square both sides and get rid of that square root. So let's square both sides. Okay, 4x minus 10 squared. 4x minus 10 squared. What are we going to have in that case? Okay, we're going to have 16x squared. We're going to have 16x squared. So let's do that. 16x squared. And then 4x multiplied by minus 10, that is minus 40x. Multiply that by 2, minus 80x. And then minus 10 multiplied by minus 10, that is plus 100. This is equals to 4, 2 squared, obviously. 7 minus 2x. Okay, there we go. So we're going to have, I think we can divide both sides by 4 here. We can divide both sides by 4. If we divide both sides by 4, on the right hand side, we'll get 4x squared. I mean, 16 divided by 4 is 4. And then 80, how many number, which number do we multiply by 4 to get 80? That is 20. So we would have minus 20x. And then with 100 is 25. So plus 25. This is equals to 7 minus 2x. So let's group the like terms. 4x squared minus 20x plus 2x minus 18x plus 25 minus 7 minus 25 minus 7, that is 18. So we're going to get minus 18 being equals to 0. Okay, any common factor we can take? I think 2. We can divide everything by 2. Get 2x squared minus 9x minus 9 being equals to 0. So let's go ahead and factorize. In factorizing this, we are going to get 2x minus 3 multiplied by x minus 3 being equals to 0. So x is equals to 3 over 2, or x is equals to 3. Okay, with these questions, when we're dealing with square roots, we always have to test if all the solutions are actually correct. We actually have to test if these solutions are actually correct. Okay, so you substitute the 3 over 2 back into the equation itself, and you also substitute 3. In doing that, you will find out that 3 over 2 is not a solution to this equation. Only x is equals to 3 is a solution. Okay, there we go. Let's move to 1.2. That was 1.1.4. Quite an interesting question, quite a long question, but what can we do? 1.2 supposed to solve simultaneous equations. Something fancy going on there. Okay, first equation, we have a squared b squared minus 2ab minus 8. Okay, should I let a b equals to k? Am I getting ahead of myself? This is equals to 0. Okay, 2ab, a squared b squared. Okay, so let me go to the other equation. I'm going to the other equation because I have a squared here and b squared here. They're going to be problematic. They're going to give me problems, right? I want to make one thing the subject of the formula, but because of those things squared there, they'll give me a problem. So rather, let me start by equation 2. Okay, so we have log of a plus 5 base 2 being equals to 3. If we apply log loss here, it should be easy to see that a plus 5 is equals to 2 to the power 3. Okay, 2 to the power 3, 2 multiplying itself 3 times. That is 8. So we have a being equals to 8 minus 5. A is equals to 3. There we go. There we go. So now we can just substitute the value of a into this equation. Okay, so in doing that, we get 3 squared b squared minus 2 3 b, no need to use brackets, minus 8 being equals to 0. 3 squared is 9, so 9b squared. 2 multiplied by 3, that is 6, but we have b minus 8 being equals to 0. There we go. We need to factorize. We can take a common factor here of 9 and 6. So, well, we can take 3 in 9 and 6, but we can't in 8. So issues are going to arise either way. So we need to factorize from this point, of which when we do that, 3b minus 4 multiplied by 3b plus 2 is equals to 0. So b is equals to 4 over 3, or b is equals to 2 over 3. There we go. We have our solutions. I think we can all agree that factorizing in this question 1 is not an easy task. It's not really an easy task. Yeah, because we always have some coefficient of x squared that is not 1. Okay. Anyway, stories 1.3. If p is equals to whatever that is, so p is equals to square root of x plus 2 divided by square root of 16 minus x squared, for which values of x will p be real. So p needs to be defined. P needs to be defined. Let's start with the numerator. In the numerator, we need x plus 2 to be equals to or greater than 0. Because if it is negative, p is not going to be defined because it's not going to be real, because we can't take a square root of a negative number. So one of the conditions that we need is for x plus 2 to be greater or equals to 0. Obviously, this says that x must be greater or equals to minus 2. Okay, so we've dealt with the numerator. Let's deal with the denominator. Okay, in the denominator, we still need that to be positive. We need that to be positive. Because if it is negative, square root of negative will get undefined. Our answer will be non-real. But not only do we need it to be positive, we need it to be greater than 0, because we cannot divide by 0, unlike in the numerator. The numerator can be 0, no problems, but the denominator cannot be, our denominator cannot be less than, so cannot be equals to 0. Right, so we're going to get 16 minus x squared being greater than 0. We need 16 minus x squared to be greater than 0. We need 16 and x squared to be greater than 0. Okay, so what can we do? We can find our critical values. X squared is equals to 16. And then x is equals to 4, or x is equals to minus 4. These are our critical values. But we would need x to lie between minus 4 and positive 4. Because if we substitute a number that is greater than 4 here, for instance, let's say we substitute 5. We're going to get 5 squared, which is 25. 16 minus 25 will give us minus 9, which will be undefined. So we need x to be between minus 4 and 4. Okay, so this is what we have. We need to combine that. We need to write that as one thing. So take a look. Here we are saying that x needs to be greater or equals to minus 2. Here we are saying that x needs to be greater than minus 4. Okay, so we can all agree that x needs to be less than 4. That is not negotiable. We just need to find another term here. That is going to be decided by this minus 4 and this minus 2. Well, which includes the other, essentially, is the question. Or it's quite an interesting case. It's quite an interesting case. Okay, because think about this. We have minus 2. Let me not start with minus 2. Minus 4, minus 3, minus 2. One of the conditions is that x must be greater than minus 4. So it can be minus 3. But the numerator is saying, no. We need x to be greater or equals to minus 2. So we cannot have the denominator be satisfied and the numerator not be satisfied. So if we satisfy the numerator, what satisfies the numerator automatically will satisfy the denominator, because minus 2 comes after minus 4. Okay, there we go. So that is our solution for 1.3.